Each discovery we make, drive, Mitchell began, her voice steady but filled with the excitement of a scientist on the brink of an extraordinary era, teaches us more about ourselves and our place in this vast cosmos. Yet, even as we find more Earth-like worlds, we must confront the truth. How can we be sure that life exists elsewhere? What defines a planet as truly Earth-like, beyond just being in the habitable zone of a star? She paused, allowing her words to sink in. Is life on an exoplanet always going to resemble life on Earth? Or could life, if it exists, be radically different from what we imagine? Could an alien civilization not only be technologically advanced, but fundamentally unlike us in ways we can barely comprehend? The room grew quiet, as researchers, engineers, and thinkers reflected on the enormity of the questions posed. It was a reality that humanity would have to face head-on. The search for life, while tantalizing, was increasingly complicated by the unknowns. Scientists had to define new terms for habitability, extending the boundaries of their search from Earth-like to a broader concept of life-friendly planets. One breakthrough came in 2036, when a collaboration between NASA, ESA, and the Chinese National Space Agency launched the first wave of deep space probes designed to enter the next frontier, the Proxima Centauri system. Proxima Centauri, the closest known star to the Sun, had long been a target for the study of its habitable planet. Proxima b, this project, named Odyssey, was designed to send autonomous exploration units into this region to scan for signs of life. The probes used advanced spectrometers to analyze the atmosphere of Proxima b, searching for chemical markers that would indicate biological activity. What they found was unprecedented, unusual patterns in the atmospheric gases. While they didn't find clear evidence of life, they identified irregularities in oxygen levels, suggesting potential seasonal changes or biological processes unknown to Earth science. This discovery opened a new set of theories about the potential for life forms adapted to conditions vastly different from those on Earth. Meanwhile, the public's fascination with exoplanets was growing, with people around the world eagerly following the latest findings. Media companies, once focused on Earthbound concerns, began to run regular features on space exploration, with entire documentaries and series dedicated to the search for life on distant worlds. Young students, inspired by the likes of Drive, Mitchell, began pursuing careers in astronomy, astrobiology, and aerospace engineering, eager to be a part of humanity's journey into the cosmos. But the true turning point came in 2040, when the largest radio telescope ever constructed, the Event Horizon Array, became operational. The array was a network of thousands of radio dishes scattered across Earth, all linked together to form a super-sensitive instrument capable of detecting even the faintest signals from exoplanets. One evening, as the world watched with bated breath, the scientists operating the Event Horizon Array detected a signal from the star system HD 85512, located 35 light-years away. The signal was a burst of electromagnetic waves, unlike anything they had ever encountered. After months of analysis, the researchers concluded that the signal was artificial in origin. It was a sequence of radio pulses, systematically organized, with the kind of precision that suggested intelligent design. The world was stunned. Was this the first sign of extraterrestrial intelligence? For weeks, speculation ran wild. Some believed it was a sign of an alien civilization reaching out to humanity. Others thought it might be a cosmic anomaly. Drive, Mitchell, always the pragmatist, urged caution in the interpretation. Before we make conclusions, we must remember the vastness of space. There could be many explanations for this signal. It could be from a distant civilization, or it could be natural, a phenomenon we don't yet understand. Still, the possibility that an intelligent civilization might be out there, waiting to be discovered, sent shockwaves through the scientific community and the general public. The discovery sparked renewed efforts to develop technologies that would allow humans to respond to the signal, should more evidence of extraterrestrial intelligence emerge. Drive, Mitchell, though thrilled by the potential, continued her work on exoplanet research, knowing that the true path to understanding the cosmos was not just about receiving signals, but about creating the tools that would allow humanity to explore and connect with the stars. By 2050, a new generation of spacefaring technologies was poised to change the landscape of human exploration. A breakthrough propulsion system, known as the light sail, was in the final stages of testing, capable of propelling small, unmanned spacecraft at a significant fraction of the speed of light. It opened up the possibility of sending probes to nearby star systems within a few decades. One of the first missions proposed was to send a fleet of light sail probes to explore the Proxima Centauri system in detail, an attempt to get a closer look at its planets and, perhaps, to make contact with whatever or whoever might be out there. The goal was clear: to answer the greatest question of all, could there be life on these distant exoplanets, and if so, what would it mean for humanity's future? As the decades passed, the boundaries of space exploration continued to expand. In the pursuit of other Earths, humanity had not only learned more about the universe, but about itself. The search for life in the cosmos was no longer just a scientific endeavor, it had become a defining part of the human spirit, a quest to understand the nature of existence, our place in the universe, and the endless possibilities that lay ahead. The age of exoplanets had only just begun, and with every new discovery, humanity moved closer to the answers it sought, reaching out into the stars with hope, curiosity, and the unyielding belief that, somewhere among the countless worlds, there was life waiting to be found. Part 2, the decade following Drive. Sophia Mitchell's groundbreaking discovery of Kepler 452b marked a period of remarkable progress. Humanity's understanding of exoplanets grew exponentially, transforming the search for alien worlds into an international scientific endeavor. But while the discoveries were awe-inspiring, they also raised a set of profound questions. What does it mean to be Earth-like? What defines a habitable planet? And, perhaps most crucially, could humanity ever truly make contact with life beyond Earth? In the year 2035, Drive, Mitchell stood at the podium in front of an audience filled with eager minds at the Global Exoplanet Symposium. The latest advances in space technology were on display, from AI-driven telescopes capable of detecting even the faintest signals from distant stars to the development of ion drives, which might one day allow humans to reach neighboring star systems in a matter of decades rather than centuries. The science of exoplanets, exploring other Earths, in the quiet depths of space, far beyond the reaches of our solar system, exist worlds that might just resemble Earth. These are the exoplanets, planets orbiting stars beyond our Sun. For centuries, humanity has wondered if there could be other worlds like ours, harboring life, oceans, and skies. In the 21st century, the pursuit of answering this age-old question has become one of the most exciting frontiers of scientific exploration. The story begins in the year 2025, at a high-tech research facility nestled in the foothills of the Rocky Mountains. Drive. Sophia Mitchell, an astrobiologist, gazed out the window of her laboratory, where the lights of the city below twinkled like distant stars. She had spent her entire career searching for life on exoplanets, driven by the dream that one day, humankind would find a twin to Earth. "We are on the cusp of something extraordinary," Drive, Mitchell often told her team. "Every discovery we make brings us one step closer to answering the question, are we truly alone in the universe?" It was a cool January morning when the breakthrough came. The team had been analyzing data from the latest observations from the James Webb Space Telescope, a powerful observatory designed to peer deeper into space than any telescope before it. They were searching for planets that could exist within the habitable zone of their stars, the region where liquid water could exist on the surface, a key ingredient for life as we know it. Dr. Mitchell sat up straighter as she reviewed the data. Among the hundreds of exoplanets catalogued, one stood out. It was orbiting a star much like our Sun, located in the constellation Lyra, about 1,200 light-years away. The planet, designated Kepler 452b, was nearly identical in size to Earth and lay within its star's habitable zone. It was the holy grail of exoplanet discovery, a true Earth twin. "This is it," she whispered to herself, excitement bubbling in her chest. The science of exoplanets has taken a giant leap forward. The planet Kepler 452b had been discovered several years earlier, but the new data from Webb's infrared sensors provided an unprecedented look at its atmosphere and surface conditions. It wasn't just Earth-like in size and orbit. The atmospheric composition showed traces of oxygen, methane, and carbon dioxide, all signs that biological processes could potentially be at work. News of the discovery spread like wildfire. Media outlets across the globe announced the findings, and scientists scrambled to analyze the data further. Drive. Mitchell's team became the center of attention, hailed as pioneers in the search for alien life. But while the world celebrated the potential for life beyond Earth, there was a sobering realization. The vastness of space meant that exploring these distant worlds would take generations, if not centuries. The technology simply didn't exist yet to send probes to planets located hundreds of light years away. Still, there was hope. In the coming years, space agencies around the world, NASA, ESA, and private companies, began to focus their efforts on developing new propulsion systems, telescopes, and techniques to study exoplanets more closely. Missions like the upcoming ExoMars rover and the construction of the HARP-X space telescope, designed to image exoplanets directly, promised a new era of exploration. As Drive, Mitchell and her team continued to analyze Kepler 452b, their minds turned to the long-term goal of finding a way to send a probe to study the planet firsthand. The first step, however, was a more detailed understanding of the exoplanet's atmosphere. Was it truly capable of supporting life, or were the signs merely coincidental? The team used advanced spectrometers to analyze the planet's light spectrum. What they discovered was nothing short of extraordinary. The composition of Kepler 452b's atmosphere revealed signs of water vapor, cloud cover, and even large surface lakes. If those lakes were filled with liquid water, they could support a wide variety of life forms. The planet's mild climate suggested that it could sustain Earth-like conditions, with temperate weather patterns, seasons, and possibly even ecosystems teeming with life. As the research continued, new discoveries poured in from other exoplanets. Scientists began cataloging a growing list of planets that seemed to share characteristics with Earth. Some were smaller and rockier like Earth, while others were gas giants like Jupiter. Some orbited stars that were cooler and redder than our Sun, while others circled stars much larger and hotter. Yet all of them had one thing in common: the potential for life. In 2030, a bold mission called the ExoLife Expedition was launched. While not able to travel to distant planets just yet, the mission sent a fleet of autonomous spacecraft to study exoplanets up close, taking detailed images, spectrographic data, and environmental readings. For the first time in history, humanity was able to examine the atmospheres of exoplanets in real time, gaining vital clues about the potential for life across the galaxy. Drive, Mitchell, now a leading figure in exoplanet research, stood before a large screen, watching as a probe transmitted data from a planet orbiting a red dwarf star. The planet, known as Proxima b, was one of the closest potentially habitable worlds to Earth. As the data came in, a collective gasp filled the room. The atmosphere was thick with nitrogen, and the presence of oxygen and ozone layers suggested that complex life might have evolved there, too. We may not be alone, Drive, Mitchell thought to herself, as tears welled in her eyes. The journey to explore other Earths had only just begun. In the coming decades, humanity would discover thousands of exoplanets, some of which might bear the fingerprints of intelligent life, while others could harbor microbial life forms, still others completely barren. But the search for exoplanets had already changed the way people viewed their place in the universe. Through the tireless work of scientists like Drive, Mitchell and her team, and with the collaboration of nations, humanity began to realize that the universe was not just a vast, empty expanse, but a teeming field of possibilities. The science of exoplanets had opened the door to a new chapter in the story of life, and the dream of discovering other Earths, worlds not unlike our own, had become an exciting reality.